Thank you so much for watching our previous videos, and we've just solved question 1, and let us look at the second and the third problems. Please do not forget to always like, subscribe, share our videos, and more importantly inform others to also learn from this. Now let's look at the second question 2 on the board. We are told to solve the equation 4 raised power x plus 2 raised power of x plus 1 minus 24 is equal to 0. So, seeing 4 raised power of x, we can write 4 raised power of x as 2 raised power of 2x, because 2 to the power 2 is equal to 4. And because through algebra we obey the commutative law, so 2x will be the same thing as saying x2, or we can say 2 times x, same thing as x times 2. So we can write this as 2 to the power x times 2. So here we can write this 4 raised power of x as 2 raised power of x index 2, then plus, let's look at this. We know that a to the power m times a to the power n is equal to a to the power m plus n. So we can look at 2 raised power of x times 2 to the power of 1 to be equal to 2 raised power of x plus 1. So our 2 to the power x plus 1 here can be written as 2 to the power x times 2, so that we will have 2 into 2 to the power x to replace this minus 24. Now at this point we can decide to say let p be equal to 2 to the power x, so that this will become p squared plus 2p minus 24 is equal to 0. So we can factorize this um, in our factoring method by looking at the factors of negative 24. So we have negative 24 here. We can look at um, 1 times 24. We can look at 2 times 12. We can look at 3 times 8. We can look at 4 times 6. Now, and vice versa. We see that if we attach the minus sign to 4, we are going to have 6 minus 4. And this will be correct because this is plus 2. So you are going to choose minus 4 plus 6 to have plus 2. So here we are going to have p squared, we split into p times p is equal to 0. So you are going to have minus 4 plus 6. So using the additive inverses of these numbers, let me write it on the other side so that you can see it clearly. So we have p minus 4 is equal to 0, or p plus 6 is equal to 0, which implies that p is equal to 4, or p is equal to 4, or p is equal to minus 6. But we recall that from the beginning of the solution that p is equal to 2 raised power of x, which means that from the first part, 2 index x is equal to 4, which is the same thing as 2 to the power of 2. Then if we equate the powers, since we have the same basis, it implies that x is equal to 2. Now let's take the other part. If you pick 2 to the power x to stand for p, that will be equal to minus 6. And because you cannot express minus 6 as a power, you may give us a different type of number. We feel that the only true solution to this problem is x is equals to 2, and not the second solution. Now let's go to the third problem. Hoping that you can copy this very fast. So I'll write again that x is equals to 2. Now let's look at the third question. Now we have 0.2 raised power of x minus 0.5, all over square root of 5 is equals to 5 times 0.04 to the power of x minus 1. Now let's look at the board very well for this. If we rewrite 0.2, which is a decimal, as a fraction, that will give us 1 over 5. If we rewrite 0.5, which is a decimal as a fraction, that will give us 1 over 2. How about 0.04? That is 4 over 100. Now, if we use 2 to break down this will give us 1 over 25, which we can write as 1 over 5 to the raised power of 2, because the square of 1 is still 1, but the square of 5 is 25. So with this in mind, we are going to substitute um, these fractions for the decimals on the board. Let me also explain something else. We have 5 here. 5 is the same thing as 5 over 1, because this is a rational number. And that is the same thing as saying 1 over 5 raised power of negative 1. Why? Because in indices, a over b raised power of n is the same thing as b over a raised power of negative n. That is a rule of indices. So with that in mind, we can now substitute each of these and make all the terms of this question to have a base of 1 over 5. Let's try that and see how it look like, because this will make the question to look so beautiful and will make the solution very easy for us. So we can solve this by expressing 0.2 as 1 over 5. Then we have x minus 0.5. Okay? Now, we know that if we isolate the numerator here, we are going to have 1 all over square root of 5. And square root of 5 can be expressed as 5 to the power of 1 over 2. That is square root of 5. So, we know that 1 over 2 is something as 0.5. And then, but we are talking about 1 over square root of 5, which is the same thing as saying 5 raised power of minus half, which is the same thing as saying 5 raised power of minus 0.5. So that solves a lot of problems. So we are going to simplify that, so that we are going to have times 1 over 5, in this case to power 0.5. Okay, then is equals to 5. We can write that as 1 over 5 raised power of negative 1. Then times 1 over 5 raised power of 2. Then times what we have here, which is equal to x minus 1. So you can see that all the bases have the same base, the same values, 1 over 5, all true. So we can now simplify the powers. Okay, so we now have x minus 0.5 plus, because of the multiplication sign, 0.5 is equals to negative 1 plus what we have there is 2x minus 2 if we expand the brackets. Minus 0.5 plus 0.5 is equal to 0. So we have x is equals to negative 1 minus 2 will give us negative 3. So we have 2x minus 3. Okay, so we're using additive inverse of x. It implies that we are going to have 2x minus x minus 3. Okay, so that automatically gives us is equal to 0. X minus 3 is equal to 0. Now at this point, we can use additive inverse of 3 minus 3, which is negative 3, so which is 3, so that we can have that x is equals to 3 as the solution to the last problem. If there's anything you don't understand, please make comments in the comment section. Do not forget to subscribe to this channel, share this video so that others may learn from it. Thank you so much for watching.